Hi, and welcome to today's tutorial. Today we want to look at this question under the topic polynomials. A polynomial P is defined on the set of real numbers R by P of x is equal to 4x cubed plus 4x squared minus 11x minus 6. Given that 2x minus 3 is a factor of P of x. A. Factorize P of x completely. B. Solve the inequality P of x less than 0. All right, so we want to present a step-by-step solution to this question. So please follow from the beginning right to the end. And if any questions, don't hesitate to indicate to us in our comment section. A polynomial P of x is given as 4x cubed plus 4x squared minus 11x minus 6. And then we are told that 2x minus 3 is a factor. Okay, if it's a factor of P of x. If 2x minus 3 is a factor of P of x, it therefore means that this polynomial P of x, when divided by 2x minus 3, we are going to have the remainder 0. All right, the remainder will be 0. So let's carry out that Euclidean division and see. We have 4x cubed plus 4x squared minus 11x minus 6 divided by 2x minus 3. All right, so what do we write up here? Remember, whatever we write up here should be such that when we multiply back, we'll at least eliminate this first member 4x cubed. All right, we're going to do subtraction. It's the same thing that happens when we carry out Euclidean division with numbers. We expect to have 4x cubed here. So what do we write up here? When we multiply back, we're going to get 4x cubed here. It should be 2x squared. 2x squared. All right? So 2x squared multiplied to 2x is going to give us 4x cubed. 2x squared multiplied to negative 3 is going to give us negative 6x squared. And we're doing subtraction. This subtraction goes for all of this. All right, so 4x cubed minus itself, 0. All right, that's our purpose. This first member should always end up with 0 when we carry out that subtraction. Then now 4x squared minus minus, this becomes plus. Minus minus gives us plus. So 4x squared plus 6x squared, it gives us 10x squared. All right, we'll bring down negative or minus 11x. Minus 11x. We'll bring it down. All right, so what are we going to write up here? So that when we multiply back, we're going to have 10x squared in the first position. All right, we'll be doing the same thing just like we did here. So what should we write here so that when we multiply back, we're going to have 10x squared? You see, it should be what? It should be plus 5x. All right, so 5x multiplied to 2x, it gives us 10x squared. 5x multiplied to negative 3, it gives us minus 15x. And we're doing this subtraction. Okay, the subtraction goes to all the elements in this second expression. All right, 10x squared minus itself, 0. All right, we'll achieve 0 as we progress. The first member should always subtract to give us 0. Negative 11x minus minus again. Remember, minus minus gives us positive. All right, so we have minus 11x plus 15x. So it's like 15 minus 11, that gives us 4x. All right, we'll bring down negative 6. We'll bring down negative 6 there. All right, what should we write here? So that when we multiply, we're going to have 4x here. So that when we subtract again, remember subtraction, we should end up with a 0. Look at it, 0, 0, 0. We should obtain 4x here when we multiply back. So you see, it should only be what? Positive 2. Positive 2 multiplied to 2x gives us 4x. Okay? Gives us 4x. Positive 2 multiplied to negative 3 gives us minus 6. So finally, you see, 4x minus 4x, 0, minus 6 minus itself, 0. All right? So it once more confirms that 2x minus 3 is actually a factor of 4x cubed plus 4x squared minus 11x minus 6. So it confirms. So now with this result that we have, we can write P of x now. P of x, remember P of x is all of this, can be written as what? Remember, if we have something 7 divided by 3, we know it is maximum 2 times remainder 1. All right, it's 2 and 1/3. So this is a quotient. This is the number of times that when this one divided by this we get. So it will be this multiplied to this. Okay, it will be 2x minus 3. All of that multiplied to that quotient, which is, let's write it down for lack of space. It will be 2x minus 3. All of that multiplied to 2x squared plus 5x plus 2. All right. So that is P of x. This P of x, this expression, it can be written as such. All right. This is already first factor. So what is left now is to factorize this quadratic expression. All right. Quadratic expression, look at it. The degree is 2. We must obtain 2 factors. Our P of x, the degree is 3. Degree is always the highest power of the variable. All right. The degree is 3. So we expect to have 3 factors of P of x. This is already the first. Here is a quadratic. We're going to obtain the remaining 2 factors when we factorize this quadratic expression. All right, so now we want to factorize 2x squared plus 5x plus 2. We want to factorize that. You can use the quadratic formula, just like you can use the factorization method. All right, let us use the factorization method, for example. All right, so our A is 2, our B is 5, our C is 2. Okay, so we need to get factors of AC. AC is 4. That's 2 times 2, 4. What are the factors of 4? We have plus minus 1, plus minus 2, plus minus 4. These are the factors of 4. So we chose from these factors of 4 to get those 2 values whose sum will be 5, whose sum will be B, and whose product is AC, 4. So which are those 2 values from this set, such that when I sum them up, I'll have positive 5. And at the same time, when I multiply them, I will have positive 4. Okay? Those factors will just be positive 1 and positive 4. All right? So we choose positive 1, choose 1 and 4. When you multiply them, you have 4. And when you add them up, you have 5. So we're going to replace now this 5 here with 1 and 4. We'll replace this 5 here with 1 and 4. So we'll now write our expression there, 2x squared plus 1 plus 4x plus 2. All right, this is the factorization method. Now we open this parenthesis. We have 2x squared plus x plus 4x plus 2. All right, now let's proceed this way. Let's proceed this way. Let's write the expression again. 2x squared plus x plus 4x plus 2. We'll factorize the first 2 and factorize the second 2. That's the factorization method. All right, if we look at the first 2 terms, we have x is common, so put x outside. Or we divide this by x, we have 2x. Divide this by x, we have positive 1. We look at the next 2 expression, we have 2 is common, so we factorize out 2. Or divide this by 2, we have 2x. We divide this by 2, we have 1. All right, the factorization process continues because we still have something common. We have 2x plus 1 and 2x plus 1 is common, so we'll factorize it out. All right, factorize it out. We're going to write 2x plus 1. It is common. When we divide this by 2x plus 1, we are left with x. And we divide this by 2x plus 1, we are left with 2. All right, so we now end up with 2 linear factors. All right, this is a simple linear factor, a simple linear factor. So we have succeeded to factorize the quadratic expression 2x squared plus 5x plus 2. All right, so now let's write our P of x as product of its factors. Therefore, P of x as product of its factor. This is the first factor. It was given in the question, 2x minus 3. That's the first factor. Multiplied now to the other two factors. We have 2x plus 1, x plus 2. All right, so p of x can be expressed as product of its factors as such. We see we have 1, 2, 3, confirming that when a polynomial is of degree 3 and we want to factorize it, we are expected to have 3 factors. These are the 3 factors of the polynomial p of x. So we have done the first part of our question, which is factorization. The first part A, it asks us to factorize p of x completely. Now the second part of our question, it says solve the inequality p of x less than 0. The inequality p of x less than 0. How do we solve that? The inequality p of x less than 0. Now, let's look at it. P of x less than 0, we just write p of x as product of its factors like we see like this. We have 2x minus 3 into 2x plus 1 into x plus 2 less than 0. That's the inequality we're asked to solve. Since we already have here simple linear factors, we just get our boundary values. We set each of them equal to 0 and solve for the unknown. So we have here x will be equal to 3 all over 2. That's the first boundary value. Set this one also equal to 0 and solve. Okay, so if we solve, we'll have x is equal to, we'll take this positive one that will become negative 1, we divide both sides by 2. That's the next boundary value. We also set this equal to 0 and solve for x. We'll have x equals to negative 2. So our boundary values are 3 all over 2, negative half, and negative 2. Next thing, we'll carry out analysis on the number line. This is our number line. We arrange these boundary values in ascending order on the number line, or in their right positions on the number line. So we have the smallest is negative 2, followed by negative half, and then the biggest is 3 all over 2. All right. Those numbers arranged on the number line, that's their real positions. We must not mix up things. So we have 1, 2, 3, 4 zones to carry out our analysis in order to get our solution set. Right? Analysis consists of taking a value in a zone and putting it there and noting the sign. All right? We take a value in each zone, we put there, and we note the sign. So let's write our expression again here. The expression we're going to be working with is 2x minus 3 into 2x plus 1 into x plus 2. We'll be doing our analysis here. All right, take a value in this zone. Remember, this is to the left of negative 2. Any value to the left of negative 2 will be found in that zone. So take, for example, negative 3. And we put there, we're interested only in the sign. 2 multiplied to negative 3 is negative 6. Minus 3 is negative 9. All right, so you'll have negative. Multiply 2. The value of taking is negative 3. 2 multiplied to negative 3 is negative 6. Plus 1 is negative 5. Again, is negative. Take that again. Negative 3. Negative 3 plus 2 is what? Negative 1. Again, it's negative. Negative multiplied to negative. Positive multiplied to negative. Negative. So here we have negative. There we have negative. Take a value in this zone. A good example of a value in this zone could be negative 1. Negative 1 is found in this zone. I will carry out our analysis and see what we get. So we'll put negative 1, we'll have negative 2 minus 3 is negative 5. So we're just on the sign. Put negative 1 here, negative 2 plus 1 is negative. Negative. All right, put negative 1 here, negative 1 plus 2 is positive. All right, so we'll multiply out. Negative multiplied to negative, positive. Positive multiplied to positive, positive. We'll take a value in this zone and we carry out the same analysis. A value in this zone, a good example could be 0. 0 falls in this zone. So if we put 0 for x, this is what? Negative 3. Put 0 for x, this will be positive 1. Put 0 for x. This is positive 2. Negative multiplied to positive, negative. Negative multiplied to positive, negative. Take a value in this last zone and we'll carry out our analysis. A value there, a good example. Remember 3 all over 2 is 1.5. So a good example could be 2. Put 2 here. 2 multiplied to 2 is 4. 4 minus 3 is positive 1. 2 multiplied to 2 is 4. 4 plus 1, positive. 2 plus 2, 4, positive. So everything, positive multiplied by positive, positive. All right. So we'll now see a sign that we get in each of those zones. Now, which of those zones will constitute our solution set, or part of our solution set? We'll go back to our inequality. Inequality says less than 0. Remember, less than 0? Less than 0. This is 0 on the number line. Less than 0 means negative. All right, values here are negative, values here are positive. So we're going to take the zones where we have negative. We're talking about less than 0. So this is it, negative. Where do we have negative? This part forms this zone forms part of our solution. This zone forms part of our solution. So our solutions lie here or there. Okay. So now let's go ahead and bring out the solution set. So our solution set will be all real values of x such that x is strictly less than negative 2. Look at it, it's strictly less. We're talking about the strict inequality. So will be x strictly less than negative 2 or, all right, we always present or with the union sign when we move from logic to set theory. All right, or means union. All right, or x belong to this zone. What is this zone? Negative half less than x, x less than 3 all over 2. Negative half less than x, x less than 3 all over 2. All right, so this gives us our solution set for the inequality p of x less than 0. All right, if you take any value in any of these zones and you put it there, it will always be less than 0. That's what it means. And less than 0 means negative. Any value from these zones, if you put it there for x and evaluate, your answer will always be negative. So that ends the solution to this particular question.